The figure below represents a speed time graph for a cheetah which covered 825 meters in 40 seconds. So the distance from here to there is 825. Now the first question is asking us to state the speed of the cheetah when recording of its motion started. That is, when the time was 0, what was the speed in meters per second? And the speed here is, you can read from the graph, because this graph has got this line, the horizontal, and the vertical. So in the vertical we have the speed in terms of meters per second, and in the horizontal we have in terms of time in seconds. So at t equals to 0, the speed at t equals to 0, the speed is equal to 15 meters per second. So the next question is the maximum speed attained by the cheetah. So the start of the motion, the speed of the cheetah is 15. So it went up to a certain point. So that point, that is the maximum speed it attained. So in the graph, it is not showing the maximum speed. So there's no value here. Now we need to find that using some concepts of speed and time. Now, you will find that there is a figure that's created below the graph. This here, this space. This is the distance covered by the cheetah, and it's equivalent to the area under that graph. So what we're saying is that below the graph, that space is created. That is an area. So the area under that graph, or the area of the space, is equivalent to the total distance. The total distance, which is 825. So how do we know the area? We are going to subdivide this shape into several figures. So if we draw a perpendicular or a line up to that point, that is at time or at t equals to 10, and then draw another figure at t equals to 20, we are going to have the height of that figure. The height of that figure is equivalent to the maximum speed of the cheetah. So we have how many figures here? We have 1, 2, and 3. Now the area of 1, 2, and 3, when you add them together, it's equivalent to 825. So the first area is a trapezium. Let's call it area of 1 is a trapezium. How do you get the area of a trapezium? The area of a trapezium is equal to a half addition of the parallel sides multiplied by height. So this is the same as a half into bracket. The parallel sides are these sides, which is one is 15, the other one we don't know is h. Then you multiply the height of the trapezium, which is 10, from 0 to 10. So that is the same as 10. Now simplifying further, this will give us, if we open this bracket, that's the same as 75 plus 5h. Now we come back to the area of 2. The area of 2 is a rectangle with and the length of h. With the width of the rectangle is from 10 to 20. So the difference is 20 minus 10. That is the same as the width is 10. And the length of the rectangle is h. We don't know. So the area of a rectangle is length times width. This gives us 10 times h. Then the area of 3 is a triangle, and the area of a triangle is given by a half times base times height. So this is a half times, the base is from 20 to 40. That is a difference of 20 seconds. That is 40 minus 20. The length is 20 times the height, which is this one. Still we don't know. So this gives us again 10h. So when we add them together, 75 plus 5h plus 10h plus 10h, this is equivalent to 825. So collecting the like terms, 5h plus 10h plus 10h, that is the same as 25h. Then if we take 75 to the other side, this is the same as 825 minus 75. So 25h is equivalent to 750. Dividing both sides by 25 gives us the height as 30 meters per second, because that is the maximum speed attained by the cheetah. Here it will be 30. So the next question is finding the acceleration of the cheetah in the first 10 seconds. So acceleration, abbreviated as ACC, is equal to the change in speed over the time taken. So the change in speed, we have the final speed minus the initial speed divided by the time taken. So the final speed, that is in the first 10 seconds, the speed at t equals 0 is the maximum speed, which is 30, minus the initial speed, which is 15, divided by the time taken. So that's the same as 15 over 10, and the acceleration is 1.5 meters per second squared. So I will leave you with Roman 2. I want you to get the acceleration of the cheetah in the last 20 seconds. Let me know in the comment section. So part D is asking us the average speed. The average speed of the cheetah is equal to the total distance over total time taken. So we know the total time taken, you're told, in the first 20 seconds, but we don't know the total distance, that is from t equals to 0 to t equals to 20. But we can know if we subdivide that figure into let's say figure A and figure B. So we can know the total distance, because we said initially that the area under the graph is the same as the distance. So we need to get only the area of figure A and figure B. Now that we know the height, which is 30 in both cases, we need to find the total distance is the same as the area of A plus the area of B. So what is the area of A? The area of A is a trapezium, and that will be a half 15 plus 30 times the height is 10. This is the same as 45 times 5, which gives us 225. The area of B is a rectangle, and the rectangle has a width of 10 and a length of 30. That gives us 30 times 10, which is 300. Total distance is equal to 300 plus 225, which is the same as 525. So the average speed is 525 divided by the total time, which is 20. That gives us 26.25 meters per second.